Unit 3, Lesson 10. So in this lesson, we'll determine what is rotational symmetry, how do we determine the order of a figure, and how do we determine all angles of measure that can be rotated, that a figure can be rotated to coincide or map to itself. So the vocabulary terms I'm not going to go over specifically because I'm going to go through them in the lesson, and it'll make more sense within the context of the lesson. So for the lesson, rotational symmetry is when an object has a center point. Okay, again, rotations occur about a center, about which the object is turned or rotated a certain number of degrees, and then the result is that the object looks the same. So in our formal definition up top, it says if the figure is the image of itself under a rotation about a center point. Okay, we don't count 0 degrees because that's the start position of the figure, and a rotation of 360 we know returns the figure to the start. So a figure, if it only rotates 360 degrees to map back to itself, that does not have rotational symmetry. It needs some other angle measure that it can rotate by to map back onto itself. So for example, let's take a look at this triangle. Right, so it's asking us, okay, if I rotate this, it doesn't look the same yet. Still doesn't look like it's back in its original position. I have to go a full 360 with this triangle. So this triangle here does not have rotational symmetry because only a rotation of 360 degrees maps the triangle back to itself. So let's try the rectangle here. And let's see if it will keep these together. Okay, so let's look. Again, we want the rectangle to look exactly the same as it is. So as I'm turning it, it doesn't look the same, it doesn't look the same, it doesn't look the same. I've only gone 180 degrees, but the rectangle looks exactly the same as when it started. Right? It maps back onto itself. And I can keep going the full 360, and again it looks the same. So because there is an angle measure between 0 and 360, that puts that image back onto itself. This does have rotational symmetry. Let's take a look at the hexagon. Okay, so it looks like this, and it looks like that again. And if I'm rotating, it looks like that again. So there's some angle measures between 0 and 360 degrees that does make that hexagon look exactly as it did at the start. So yes, again, it does have rotational symmetry. Let's look at the, not sure why these got moved up. Let's look at the parallelogram. Okay, I'm turning it. It doesn't look the same. It doesn't look the same. It doesn't look the same. It does look the same, and I have not gone 360 degrees yet, so there is some angle measure between 0 and 360 that does map this parallelogram back onto itself. Let's take a look at the S shape. Again, I'm rotating. There's 90. There's 180. It looks exactly like it did at the beginning. And again, at 360, it looks the same. So again, there's an angle measure between 0, not including 360, because again, if it just goes 360, that's not sufficient for rotational symmetry. All right, lastly, let's look at this recycling sign. Oh, that picture looks the same. That picture looks the same. And we're back to our original picture. So again, there are angle measures between 0 and 360 that have rotational symmetry.